Get ready, get set, and let's go for 4.3, dealing with inequalities. We are solving inequalities at first here. Nothing we can't handle. I hope you're having a great day. We're gonna take a look at what's going on. For 1 through 7, apply each operation to the original inequality. Then ask yourself, is the resulting inequality true or falso? In this example, we're adding 3 to both sides. So -9 plus 3, 2 plus 3 gets you 5. This is then claiming that -6 is less than 5. So that's what this is claiming. -6 is less than 5. And they're saying that's true, because having a positive version of a number is greater than having a negative version of a number. So we pretty much just rinse and repeat the same inequality, but just with a different step this whole time. So let's see how the rest of these go. What's problem 1 asking us to do? Subtract 7 from both sides. All right, so I'm just going to rewrite my inequality. -9 less than 2. If I deduct 7 on both sides, -9 minus 7 is going more negative. So -16, 2 minus 7, we're now dipping into the negatives, -5. And so this is saying that -16 is less than -5. What do you think? Is that true or false? Cierto o falso? Cierto, true. -5 isn't as negative as -6. So we say that that's a true statement. Let's bang out the next few. Add 15 to both sides. Sure. So start with, again, original inequality was -9 less than 2. If we add 15 to both sides, our right side is going to be 17. -9 plus 15 gets you 6. This is claiming that, well, what's it claiming? What do you think? What's being said? Take a gander. Think about this. Hopefully you're saying that -6 is less than 17. Sorry, not -6. 6 is less than 17, which is true. All right. Leave 10 to you. I don't think 10's asking too much. I would like to talk about -6 though, multiplying on both sides. So let's break that one down. So we're going to start same song and dance. -9 is less than 2. That was the other side, right? Yep. Okay. And then problem 6 is asking us to multiply both sides by -6. So multiply by -6 here and here. So take your time here. -9 times -6. What do you think that's going to be? Hopefully you're saying it's going to be a positive 54. If you're not convinced, negative times a negative, and I'll highlight this because this is a huge deal where I see students trip up. Negative times a negative gets you a positive. 2 times -6 is just going to get you -12. So what do you think about this statement? Which side is greater? Left side's positive, right side's negative. So this means that our sign has to switch. So please take note of this. This was a switch. In particular, and the reasoning why, we're multiplying by a negative number. So when multiplying or dividing by a negative number, switch the sign. Huge, such a big deal. So it's only now that this is true. Because if you just left, if you just are walking into the video and you think, oh, I don't have to switch the sign, who cares? Think about what that's saying. That's saying that, it's saying something pretty wild. It's saying that positive 54 is less than a negative 12, and that doesn't make sense. That does not make sense. So it doesn't work. So you have to switch the sign if you're multiplying by a negative number or dividing. I almost don't even want to write this because it's so false. So don't fall into that trap. Switch your sign. 7, you're going to be switching your sign. You'll write pretty much a conclusion for 8, which says the same thing we already talked about. So that's the go. You're solving literal equations. You've done this quite a bit. These are just amplified a little bit more. So solve for h. Well, what's the operation between 25 pi and h? Are they adding to each other, multiplying to each other, dividing? Hopefully you're saying that you see multiplication, but you want to undo it. Yikes. What's up with this? All right, you're undoing it with division. And we're going to do this in one shot. So we're going to divide both sides by everything that's not h, which in this case would just be 25 pi. So everything that was not h, which includes 25 pi. 25 cancels, pi cancels. We're left with h equals q over 25 pi. And we're done. We solved for h. Take it some time. Try 10. Pause the video. Try 10 real quick. Should have paused the video and tried it. You should eventually say that h equals q divided by pi r squared. Pi r squared and h, we're all multiplying. So undo them all by using division. They cancel. H is left over. This is what you should have gotten. Hope that helps. Let's see what else is going on. You've seen problems like 11 and 12 before, so they shouldn't be too tricky. I think this one might have been on your 4.2, 4.1 quiz, but let's chat about it. We're solving for m, so maybe we want to fall back on what we've done before, where we make a goal, and we want m to be equal to something. That's a good way to start these off. So I know that m's right here. M's kind of buddied up with 7 right now, so we'll get to that in a second. But what's on the right side that's not the 7m? Hopefully you're saying the 6. So we see a positive 6. And so we're going to undo that with a negative 6 on both sides. So y minus 6 now equals 7m. We see 7 multiplying with m. So we see 7 multiplying with m. To undo that and keep m where it is, we're going to divide by 7. So we're going to do that here and here. The equations start to look pretty wild, and I hope that's okay with you, because we're still making safe moves whenever we solve these. We're still being strategic. So m equals y minus 6 dividing by 7. Take a moment, try 12. 12's done for you. Hopefully you got something along these lines. Hopefully you challenged yourself to try the problem. That's the way that this is going to stick if you're actually trying these problems when I tell you to try them. Pause the video if you don't have 12, but definitely make sure that both of these are copied. That's what I'm going to look for. And that's what I'm going to ask you about when you're all said and done taking these notes. We got a little reciprocal action here. Recall that the reciprocal is this fraction but flipped. So in this case, our reciprocal is going to have 4 up top, 3 in the bottom. We can be real savvy and multiply both sides by this fraction. This 4/3. 4's cancel, 3 cancels. This leaves us with x minus 2 equals 12. Multiplying with all this, so I'm going to just say it's dividing by 1. 4 times 12 is 48. Dividing by 3 times 1, which is 3. So this is really just 16. This looks like something you could solve, right? Very quickly. Just add 2, x equals 18. Pause the video, try 20. You should have done pretty much the same steps I did for 19 using your reciprocal, adding 2y now. Be careful, you were adding 2y to both sides. You can't combine 16 and 2y, so just write them as is, just 16 plus 2y, and that does it for that one. The Go has us identifying x-intercepts and y-intercepts. Well, maybe let's do a quick refresher as to what those look like when graphing. So when we're graphing, we have our x-axis. It goes from left to right indefinitely. We have our y-axis going up and down like a clown. Let's switch up the color for this. Our x-intercept is going to occur where x is 0. And our y-intercept occurs when x is 0. Our x-intercept occurs when y is 0. So switched. So that's a big thing to look at. If we had this line going like so, we would have this as our y-intercept. I'm not too sure what the y-coordinate is there, but that's what it would be. And this down here on the x-axis would be our x-intercept. So that's what we're going to be looking for. We're looking for zeros for the coordinates. So in this, I see that my x-coordinate's 0, the outcome's 4. So this is definitely my y-intercepts. Where, again, x is 0, the outcome is 4. So that's our y-intercepts. Do we have an x-intercept for 21? We do, right here, x-intercept, in this case, is going to be 2, 0. Again, you're looking for zeros, so look for zeros. I'll just highlight where these are for the next few. And I want to say that's pretty much it. The graphing's not too bad. Look for where they are. I kind of drew that out in the first one. You have some problems down here justifying your steps. So those take some time, but just think about each step and give some reason as to why they work. The first example's done for you, I believe. Yeah. So if you got any questions, holler, let me know, say something. Thanks for watching.